This is a timer. What about the work done by the force as it moves from O to A, B to C, C to D, and D? What just work done? I'm just asking positive or negative. How from XT graph can we say work done? From position versus time graph, can you calculate the slope? So look at the slope for this. If you calculate slope in position versus time graph, what you get? You'll get this velocity, no? Or the speed. So look at the slope from O to A increasing. So therefore the speed is increasing. So work done by the object on from O to A will be positive. What about A to B? Slope constant. If slope constant, then path OA, I think I'll write it here. Path OA, speed increases. Slope increases, positive slope increases. Slope increases, so therefore V increases. What is the reason for that? What do you mean by slope here? Slope is equal to dx by dt is equal to V, no? Finish over. Now path AB, slope constant. So therefore V constant. If V constant, no change in speed, so what is work done? Will be 0. For path BC, slope decreases, no? Slope decreases means what does it mean? The speed decreases. Speed decreases means kinetic energy decreases. So work done will be negative. What about CD? Magnitude of slope we are bothered about because what is the speed? Speed is magnitude of slope. So what's happening to slope when you move from C to D? Slope will increase. I think you should not bring your mathematics into picture here. I'm asking magnitude of slope. So speed in fact increases. So work done here C to D will be positive. What about D to E? The negative slope decreases, the magnitude decreases. Path D, slope. Don't think in terms of mathematics. Now you know enough of kinematics, everything. So what about path C, D, E? It will change direction of motion. That's all here, no? Here velocity for O to C, velocity positive means for C to E, the velocity will be negative. So they should be negative. So if they give XT graph, can you position versus time graph? Yes, there's a method of predicting about the work done. Sir, if they give directly the VT graph, can we say about the work done? Directly the speed versus time graph. Work done positive or negative? So I'll give a graph like this. This is a 10. And this is -1. This is 2. This 4. Now, can you say anything about the work done? Directly look at initial value, how much it is. Initial speed is how much? 10 meter per second. Finally, how much? 5 meter per second. What happened? The speed decrease, no? Network done positive. Network done negative. Finish or nothing to do. At t equal to 0, what is the speed? 10 meter per second. At t equal to 4 seconds, what is the speed? 5 meter per second. Look at the speed increase or decrease? Decrease. So network done negative. So what all you'll get it? The active straight away, if they give speed versus velocity versus time or speed versus time, directly look at the speed there. From where to where is asking. Look at directly the speed. Look at the initial final speed. Final speed more than initial speed, work done positive. Final more than initial speed, work done positive. Final speed less than initial speed, work done negative. XT graph, you have to look at the slope. If they give AT graph, if they give acceleration time graph, I think we have to work out. We have to calculate the interval of time, because from 80 graph, we cannot say anything, but we can find out the speed. Because from 80 graph, what you get? The area under 80 graph will give change in speed. Once you know speed, then you can say about the work done, positive, negative. So you have to work out even the graphs. Even for this week, the graphical things also there. So tomorrow we'll focus more on such all different types of numerical. So today, what happened? You come across the conservative, non-conservative forces, different types of forces, how the work done, and the generalized method what you learned, and also some graphs I introduced. So try to work out all different things, because tomorrow evening, no, you get very less time to prepare for Saturday exam. So maximum today only graphs, different types of forces, work done, conservation of mechanical energy, work energy theorem. All related to this, you try to put effort. Vertical circular motion next week. I posted syllabus, no, again, it's there in the syllabus clearly mentioned.
Sir, it is there for this week. Sir.
No, next week it will be there. Okay,